Hi guys, hope you had a good middle break and got your mind refreshed under this pandemic. The topic for this week is the Advanced Spring MVC. We will talk about some of the core content along with the demo of the project. So let's get started. As you notice on the specification, there are some prerequisites for creating this Spring MVC project, such as Maven, which is an automation build tool, Tomcat as our application server, and MySQL to be as the database. You can simply follow the instructions provided on the tutorial specification. As this video is specifically targeting for the Mac user, I will recommend using the package management tools like Homebrew to handle these dirty work for us. So just give you a bit of instruction around the Homebrew. Basically, Homebrew is a package manager for MacOS or Linux system, which simplifies the installation process of different softwares. It's a free and open source tool. So here what we are trying to do is to install Maven and Tomcat through the Homebrew command. But first we need to have the Homebrew set up in our machine. So you may find all the detailed steps on the README file in my Git repository as showing up here. Let's just copy and run the command first to install Homebrew in our system. In our case, let's just copy this shell script command and paste it into our terminal and hit enter. It may need to spend a bit of time to download and install some dependencies for Homebrew. So after the Homebrew installation is done, you can check your Homebrew setup by typing brew config, and all the details of the environment will be showed up. So let's install Maven by running the command brew install Maven. But before that, if you have already got a Maven with an old version in your system, you might need to update the Maven by following these instructions here in the README file. So let's go back. In my case, I don't have a Maven on my system, so I will just do brew install Maven and hit enter, and then Homebrew will handle the installation of the Maven. So after the Maven is installed, we can check it by typing mvn-v or mvn-version to make sure the Maven has been successfully installed on your machine. Next, we need to install Tomcat. The process will be similar to what we did for Maven. Just open your terminal and use brew install Tomcat @9. The reason why we have this postfix @9 is because this will help us to avoid version issue in the future. So you can also run the command without declaring the version of the Tomcat. However, in that case, it will simply replace the old version of your existing Tomcat server, which may introduce some issues if you have already got some configuration in other IDEs. So you can follow the details of the installation process in the README file as well. So here I will just run this command. So once we install the Tomcat successfully, it might be worth to change the port number of the server, since we also use Glassfish server in our Eclipse, which uses a default port 8080. In order to avoid the occupancy of the port, let's go to the server XML file. So the way how we can locate the server.xml file is just copy this command. Or if you want to find it by yourself, you can use this brew ls tomcat @9 to get all the related directory locations of the Tomcat. So here I will simply use this command that I noted in previous. So scroll down to find where the connector is located. So here it is mentioned that the connector port is mapping to the 8080, right? So let's just change this 8080 to 8089 and just use Control X and it will ask us to save the change or not. Let's hit Y and hit enter to override the server.xml file. So in this way, it will change the server port from 8080 to 8089. Next, in terms of the MySQL database, we will recommend you to simply download the DMG package from the URL that provided in the tutorial document and install it by following the standard installation process. You may do the same thing for the MySQL Workbench as well. The Workbench is a GUI software that allows you to interact with the MySQL database with a user-friendly interface. Let's take a pause here as I'd like to highlight this database root password. Make sure you set it to be root pass, since in our Spring project we will use root pass as our password to connect to the database. After successfully installing MySQL database, you can check, bring up, and stop your database by going to the settings, MySQL. Before we go into any further, we need to create a new schema for our Pokemon project in our database. First, make sure the database is running at the background. Then open the MySQL Workbench. There should be a default connection which can be used in our case. Right-click on the connection and store the password into it, which is root pass. Once we're done importing the password, click on Test Connection to test the connectivity to our database. Double-click on the connection to go into the query window. Let's do a query, which is create database Pokemon DB, to let the MySQL create a new schema for us. After running the query, refresh the schema list and we should be able to see the Pokemon database is sitting there. We will use this database for our project. So open the IntelliJ and let's create a Maven project using Spring MVC framework. Select the Maven on the left panel and make sure the project SDK is pointing to the Java version 1.8. Take on the create from archetype and select the web app archetype, and next we will need to set up some basic attributes for our project. Here let me just put the artifact ID, and I will briefly explain about these three attributes. So the group ID stands for the ID of the project group. In the real world scenario, we may have different projects in one group. Artifact ID is the ID of the project itself to be identified within the group, and the version is just the version of the artifact under the specified group. So click on next. Here we need to switch this Maven home directory to this user local because we are using the homebrew to install our Maven dependencies. So click on next. Leave the rest as default in my case. In your case, you might need to manipulate the project location to wherever you desired to put your project into, and click on this finish. So then IntelliJ will initialize the project for us. Alright, let me expand the project and copy the given POM XML to our project, and then we can give a brief introduction around this POM XML file. So yep, so let's take a deep look over the POM XML first. The POM stands for Project Object Model. So at the top part of the file, we are declaring the project basic configurations like the group ID, artifact ID, versions, etc. So all these configurations are auto generated by what we have set before. And then move on to the properties section. So here you may notice these two new properties, which are the Spring version and the Hibernate version. So the reason why we declared it here is imagine the whole POM XML file is like a Java class. So we want to declare some global variables at the top part of the class, and then we can reuse these variables in other methods. So the same logic here in the POM XML file. So as you can see, just for one example, if you take a look of this dependencies, so here we are reusing this spring.version variable to let the Maven knows which particular version of the Spring framework that we are trying to download. So that's how they are mapping together. And so speaking of this dependency section, this would be the place where we declaring all the dependency classes we may reference from among the whole project. So we will use a lot of predefined methods referenced from these dependency classes, which reduce huge amount of development work. So moving on to the next part. So in terms of the plugin section, the difference between the plugin and the dependencies is that the plugins will be responsible for executing the tasks in Maven, whereas the dependencies are just providing the class files to help with those execution jobs. So after we paste all the content that provided in the tutorial specification, and right click on the project and go to Maven and click on this re-import to let the IntelliJ to import all the dependencies for us. If it is the first time that you are using the Maven to download these dependencies, you may allow Maven a bit of time for the downloading process. Let's copy all the files into our project and then we will go through them one by one. So first, let's take a look of the JPA config file. So the class is annotated with add configuration because this is a config class for our Spring project. And also we mapped our JPA repository to the model package, including all the entity classes and repositories. Here we declared two bins, and the first one is the entity manager to be associated with our persistent unit. Let's dive into the persistent unit XML file. Similar to what we have in the previous week's rolling project, we will declare the name of the persistence context and some database connection details in this persistence XML file. So we've also set the show SQL and format SQL to be true, since we want to display the queries in our console when we run the application. Back to our config class. The second bin is the transaction manager, which will provide all the CRUD functions for us to interact with the entity manager. This is actually the beauty part of Spring. We will see the actual implementation of these methods in a few seconds. Move on to the model layer. The Pokemon class is just a normal entity class, which follows the same pattern as we did in the previous week. However, in the Pokemon repository, instead of developing our own interface, we will inherit from the JPA repository, which introduces the core benefit of using the Spring framework. So the way how we use it is by declaring the entity class first, and followed by the type of the primary key or the ID of that entity. So here you may find that we have only exposed one search method in this repository. This is because we need to do some customization around this search method by injecting a JPQL. In terms of the add param, it's just mapping the placeholder in the query with the parameter of the method. The rest of the CRUD functions have all been predefined and handled by the Spring JPA. For the Pokemon service class, it's a bit like the management class. We declare the Pokemon repository instance and annotate it with AutoWild. What the AutoWild does is just placing the instance of the repository into this service bin class, and then we can provide all CRUD functions by calling the repo object. All these features have been defined in the JPA repository interface, and the implementation code will be generated at the runtime of our Spring project. In terms of the controller and view layer, I like to explain them with a comparison view so that you may get a better understanding around how they are working together. We will just take the Pokemon Managed page as a starting point, and the rest of the JS page are just sharing the same design pattern of what I'm going to explain here. So on the Pokemon Manage page, there will be a search bar at the top part of the page. After clicking on the search button, the form will be submitted by calling the get method, and the URL will be routed to /search section. At that moment, back to our controller, the search method will be called, the keyword will be passed in as an argument, and invoke the search function in Pokemon service. Next, the search Pokemon view instance will be created, and the result of the query will be stored on that view model by adding an attribute result with the value of the actual query result. And then on the search Pokemon page, it will loop the result property and print each instance of the Pokemon in a tableau format. Back to our Pokemon Managed page, the second part will be displaying all the Pokemon instances in a table view. As you can see, it is also doing a for each loop to print out all the Pokemon into each row. So the way how we instantiate this list Pokemon variable is that if we go back to check the Pokemon controller class, there is a method called home. You may get confused about this home method and our home page. Actually, if we inspect the request mapping annotation, we can tell that it is pointing to the Pokemon managed URL, which is exactly this page. So before the client gets the HTTP response from the get method, and the result of all Pokemons will be retrieved from database by calling the list all function. The for loop here is just for debugging, and then the list Pokemon is set to be an object and be added onto our Pokemon Managed view model. Finally, the view model is sent back to the client, and that's how all these Pokemons are able to showing up at the front end. Finally, expand the event log and click on the configure link to allow the IntelliJ to automatically configure the JPA framework into our project. After that, right-click on the project, select Open Module Settings, expand the main folder, and make sure the Java directory is marked as the source folder, and resources directory has been identified as the resources folder. Click on OK to apply the changes. In terms of the server, as I don't have a predefined profile yet, I will have to add a new configuration for the Tomcat server. So click on the Add Configuration button on the top right corner, select the plus button, scroll down to the bottom and expand all the templates. Select Tomcat server as a template, name it whatever you like. Make sure the server is mapping to the correct one. You can check it by click on the configure button right beside the application server. As you can see, the port is automatically set to 8089 as we changed before. Navigate to the deployment tab, add a new artifact, select the exploded one, and click on OK to save the changes. Let's do a quick demo. Before we run on a project, make sure our database is running properly. You can go to Settings, MySQL to bring up your database by clicking on the Start MySQL Server. Once you see the light, green light of the database, it means that your database has been successfully brought up. So let's go back to the IntelliJ, click on the play button to run our application onto the Tomcat server. So as you can see here, the query for creating the new table are showing in the log, and also if we open the MySQL Workbench, double click to connect to the database and go to the schemas tab, expand the database and expand the tables. As you can see, the Pokemon table is sitting right there in the Pokemon DB schema. So go back to our database, to our application, and go to the Pokemon Manage page, and let's try create a new Pokemon here. So I will set them to demo and make the speed to 100 and go to the Pokemon Manager page again. As you can see, the newly created Pokemon has been successfully persisted into the database. Let's double check in the database itself by right click on the Pokemon table and click on this select roles. So as you can see, the first instance is showing the one that we just created. So that's pretty much for this video. I hope you enjoy and take a bit of knowledge around Spring MVC from this video. Thanks for watching.